Okay, initial condition for inductor here, see here. Initial, that is initial condition for inductor, where I am going to consider this network. This is my inductor. Okay, voltage source V of t is connected. Due to this, I of t will flow. This is L. Okay, how I am going to write the equation for I of t? I of t is equals to 1 by L 0 to t V of t plus I of 0. Okay, this I of 0 is the initial current before the closing at I0. Okay, if this current is this I0 current at a t equal to 0 minus, okay, will be 0. If initial current through the is 0 and I not is 0, then inductor will behave as a open circuit at t equal to 0 plus, and same at t equal to 0 minus, if it's having I0 equal to some values, some amount of current, some current, okay, at t equal to 0 minus, then at t equal to 0 plus, the inductor will behave as some current source with the value I0. Fine. And here I miss this phi of t equals to I can take L di by dt. And now initial condition, okay, initial condition for capacitor, where this is my circuit with the capacitor C. Okay, this is V of t. Due to this, current will flow I of t. Okay, where the current of this capacitor is given by I of t is equal to C dVt by dt. Okay, where current through capacitor is proportional to the rate of change of voltage. Fine, and the voltage across this capacitor will not change instantaneously in a finite time. That is, it requires an infinite current through the capacitor. It requires infinite current through the capacitors for instantaneously change of voltage across it. But here it is not possible instantaneously change the voltage across the capacitor. The circuit is energized capacitor with some voltage source. Now the voltage across the capacitors is given by Vt is equals to 1 by C 0 to t it into dt plus v of 0. Okay, here also same condition at t equal to 0 minus. Okay, initial voltage, that is V naught, across the capacitor is 0. Then the capacitor will behave as a short circuit, SC short circuit at t equal to 0 plus. Okay, then next condition, if t equal to 0 minus, there will be a some initial voltage across the capacitor. Then the capacitor will behave as a voltage source of V naught value at t equal to 0 plus. Okay, now what I'm going to do, I'm going to summarize all these. See here, elements with initial conditions. Okay, now equivalent circuit at t equal to 0 plus. Okay, first we know resistance. What are the elements? Resistance, inductance, capacitance, right? See, at a t equal to 0 plus, there will be no change. Why? Because the current through the resistance will change instantaneously when we energize. That is, t equal to 0 minus is the same condition as at the t equal to 0 plus. And at a t equal to 0 plus, the inductor behave as open circuit, OC. Okay, and capacitor behave as short circuit, SC. Fine. Now coming to this, if inductor is having some initial current I0, then at a t equal to 0 plus, is behave as a current source with the value of I0. And same if the capacitor having the initial voltage of V0, okay, then it will behave as a voltage source at t equal to 0 plus with the V0 magnitude or value. Okay, now see this. How we are going to evaluate the initial condition for the circuit given. For that, what I am going to do, I am going to take one example, then I am going to show how we are going to derive those initial conditions. Okay, first one, the circuit is given like this with one switch, resistance, inductance. Okay, here this is given as 100 volt, 10 ohm, 1 Henry. Okay, I'm going to close the switch at t equal to 0. Because of that, current I of t will flow. Okay, now the question is, in the given network, the switch is closed at t equal to 0. Okay, this switch is closed at t equal to 0. Okay, with a 0 current in the inductor, it means the initial current, that is I naught, is 0 with the initial 0 current in the inductor. Now we need to find I di by dt and d square I by dt square at t equal to 0 plus. Fine. How are we going to solve this one? First, we know given at t equal to 0 minus, okay, no current flow, there is no current flow, that is I not equal to 0. So at 0 minus, I of 0 minus is equals to 0. Okay, now at t equal to 0 plus, now the circuit I am going to redraw how the inductor will behave at t equal to 0 plus open circuit. So I am going to redraw this circuit like this. Open circuit, 100 volt, 10 ohm. Okay, this is open circuit, so I equal to 0 plus. Okay, open circuit, current will be 0 because in the closed circuit only current will flow, right? Here the at t equal to 0 plus, inductor will behave as open circuit. So at t equal to 0 plus, I of 0 plus is 0. Now we found out this I. Okay, and next what we need to do? Next is, okay, here we can see we need to draw a circuit at t greater than 0. One is t equal to 0 minus, next one is t equal to 0 plus, now t equal to greater than 0. I need to redraw the circuit like, okay, 100 volt, Okay, 10 ohm, then one inductor, that is 1 Henry. Fine. Current IT will flow in the circuit. Now, okay, see here, for t equal to greater than 0, I need to apply KVL for the circuit. For to find out KVL, to find out di and d square I. Okay, now plus minus. Okay, minus to plus, plus 100, plus 100, minus 10I, then current through inductor, that is minus 1 di by dt equals to 0. This one I will 0, 100 minus 10I minus di by dt equals to 0. That is di by dt is equals to 100 minus of 10I. Okay, this is my equation 1. Now what I am going to do, at 0 plus I am just going to in equation 1, where see t at 0 plus is equals to 100 minus of 10 of 0 plus I 0 plus, that is 10 of I 0 plus, where we know I 0 plus is 0. At a t equal to 0 plus, the current through the inductor is 0 because it is a open. Now I'll get 100 ampere per second, that is di by dt. Now if I'm going to differentiate this equation, what I will get? See here, next I need to find d square I by dt. I am going to differentiate equation 1. Differentiating equation 1, d square I by dt square equal to constant 0. Okay, 0 minus of 10 di by dt. Okay, now this one. Now I will put d square I by dt square at 0 plus is equals to minus 10 di 0 plus by dt. Okay, minus 10, we know this di by dt is 100 ampere per second into 100, that is 1000 ampere per second square. Okay,